All right, so in this video, I'm going to briefly explain how we come up with the inverse sine, cosine, tangent graph. So first, let's start with sine. Here's a sine graph, and in class, you probably had a big resource page, and you started out by drawing the sine graph, and then you were asked to graph the inverse. Now I'm going to graph the inverse, but first I'm going to do that on this set of axes. I'm going to do it on a separate set of axes, okay? Now basically, inverse, you can reflect it across the line of y equals x, just like you did in class, or you can actually switch the xy coordinates, which is what I'm going to do here. Switching x and y, meaning the x-axis, which is in radians, becomes the y-axis, and the y-axis, which went from -1 to 1, becomes the x-axis of the inverse. That's why the radians are on the y-axis here. And I'm going to switch the xy coordinates. So for example, 0, 0 is still 0, 0. This is pi over 2, 1, but I'm going to switch the coordinates, so I get 1, pi over 2. This is pi, 0, but now I should have 0, pi, which is right here, and I'm just going to keep going. Fix that just quickly. Perfect. So now, the sine graph, coming back to it, it passes vertical line tests, right? Therefore, we can say that the sine function, or the sine graph, is a function. Now, let's look at the inverse sine. The inverse sine graph does not pass the vertical line test. Therefore, it is not a function. Now, what happened when the inverse is not a function? We have to make it a function by restricting the domain on the original function. Now, let's recap this real quick from what we have done before. We've done domain restriction before with parabolas. Parabolas have inverse, that is a sideways parabola. And remember, if it's a sideways parabola, we said it doesn't pass the vertical line test, so it is not a function. And in order to make it a function, we did domain restriction. We restricted domain on the original function. And how we did it is we cut the parabola in half, right? So like, let's say we only want right half the parabola where x is greater than or equal to 0. Then we only graph half of the inverse for that one. And then we also did the other half of the parabola, which will be the left side, where x is less than or equal to 0. And then the inverse for that would be this. And they both pass vertical line tests. That was a domain restriction we've done with parabola. So we're going to do the same thing for this one. We've got to restrict the domain on the original sine function, but the question is, how do we do it? Well, here are some tips to help you. When you're doing domain restriction, there's a couple things that you need to have. Maybe like 2, 3 things. Very simple. First, you must have first quadrant angles in the domain restriction. When I say first quadrant angles, it's talking about on the unit circle from 0 radians to pi over 2 radians. So on the domain restriction, you must have 0 to pi over 2 angles. So then let's go back to the sine graph. 0 to pi over 2 would be over here, right? That's part of my domain restriction, okay? Now that's not it. Let's keep going. It also says that it must have all outputs from -1 to +1. Okay, this is the domain restriction I have so far, but this one only gives me outputs from 0 to 1. So that's not enough. What if I go further? What if I restrict domain up to here? Does it give me outputs from -1 to +1? No, it still gives me outputs from 0 to +1. So that's not it. So then how about if I go backwards? Does this domain restriction give me outputs from -1 to +1? And the answer is yes. Domain restriction from this angle to this angle. Okay, this is the restricted domain. Domain restriction on the regular original sine of x from negative pi over 2 to pi over 2. From here to here, the highlighted part is my domain restriction. And if I actually figure out where that is on my inverse, 0 to pi over 2 is right here. Okay, that's this part. And then 0 to negative pi over 2 would be this part right here. So my domain restriction for sine is this, and that's why in your lesson, the range of the inverse sine became negative pi over 2 to pi over 2, because remember, domain and range switched, okay? And because of the domain restriction, this is the final graph of inverse sine. That's the only part that we want. And that's why there was a smaller version of inverse sine graph, which looked like this. I'm just graphing only that part. This is the graph of inverse sine. This is a final version of graph of inverse sine. There are no arrows or endpoints, and the curves go down this way because of the domain restriction. And the domain was from -1 to +1. Okay, so then if you're asked to graph inverse sine, this is a graph that you will be required to show with this domain and range. Okay, so then the same thing applies to cosine, inverse cosine. So here's a cosine graph. Again, cosine graph itself passes a vertical line test, so it is a function. Now I'm going to graph the inverse cosine by switching the xy coordinates. So let me label some coordinates on cosine, and we're just going to switch the coordinates. So now for the inverse cosine, I get 1, 0. I got pi over 2, 0, which becomes 0, pi over 2. Pi, -1 becomes -1, pi. And if I kept going, this is a graph of inverse cosine. Now this inverse cosine graph, again, it does not pass the vertical line test. It is not a function. Therefore, we got to restrict the domain on the cosine graph. Same step. How do we restrict the domain? Well, first, you got to have first quadrant angles. That's from 0 to pi over 2. That's always a must. You must have angles from 0 to pi over 2 when you restrict the domain. That's the rule. And then we must have all the outputs from -1 to +1. So then if you, let's say you restrict it up to that part, does it give you all the outputs from -1 to +1? Nope. It only gives you from 0 to 1, so that's not it. How about if you highlight or domain restrict up to here? Does it give you all the outputs from -1 to +1? Yes. -1 down here, and then +1 up here. Which means we have to restrict the domain on cosine to 0 radians all the way to pi radians. Domain restriction on cosine is 0 to pi radians, which ends up being the range of the inverse cosine. So then let's highlight it on the inverse. 0 to pi over 2, that's the first quadrant, okay? And then pi over 2 to pi radians will be this one right here. That window right there is the inverse cosine graph, which we will actually recreate in the smaller set of axes. So this time it goes up to pi radians from pi over 2 radians. And this is the final graph of inverse cosine. And this also has domain from -1 to +1. Okay, so then the last one, tangent. All right, so far right now on tangent, I only graphed one period. But if you were to continue, right, you would have another asymptotes here, -3 pi over 2, and your graphs will still look the same shape, like this, and it's going to continue on forever that same way, right? This is your tangent graph. So then if you were to graph the inverse, now your radians will be on the y-axis, which goes by pi over 4, because I need those pi over 4. Okay, so then now your inverse is going to be now horizontal asymptotes at pi over 2 radians. And then because you have a point at 0, 0, you also have a 0, 0 here. Pi over 4, 1 becomes 1, pi over 4. Negative pi over 4, -1 becomes -1, pi over 4. And here is your tangent graph, which is going to continue on, right? It's going to keep going like this. And then you're going to have more. Now, coming to tangent. Does it pass vertical line test? Yes, it does. Original tangent passes vertical line test, so this is a function. But the inverse does not pass the vertical line test, right? So it's not a function. We've got to restrict the domain again. And now it's repetitive. Domain restriction, you need to include angles from 0 to pi over 2. But this time, because the pi over 2 is an asymptote, it's going to be all the extension up here. Okay, it's going to keep going. You have arrow. So it's going to keep going. And then you need all the outputs from -1, but since this graph keeps going down this way, you're going to keep going down this way as well. So your domain restriction for tangent is right here. And that is going to be from asymptotes -pi over 2 to pi over 2, which are not included because those are asymptotes, so it's going to be open parentheses. We restrict a domain from -pi over 2 to pi over 2, which on the inverse would be just one period of that horizontal tangent graph, which is right here. Okay, so then range becomes -pi over 2 to pi over 2, because domain and range for inverses switch. And I am going to make my final inverse tangent graph, which is just this part, right? So -pi over 2, -pi over 4, pi over 4, and we have a horizontal asymptote at pi over 2, -pi over 2. Then we got, oops, that should be pi over 4. 0, 0, 1, pi over 4, -1, pi over 4. And here is your final inverse tangent graph. Your inverse tangent graph must still have asymptote, which is this time horizontal. And this one has a domain of all real number because it stretches to infinity both directions. Okay, that's it. Those are the graphs of inverse trig functions.